Hello and welcome to the Take Charge podcast. Ion Storage Systems joined me this week with the CTO Greg Hitz and the VP of Supply Chain Neil Ovadia sharing insight on the history of solid-state batteries, starting with why we still don't have a commercialized one. Ion Storage Systems look to change this as they share their three-dimensional approach. We talk about compression, safety, manufacturing, supply chain, and much more. I'll be watching their future with interest as they attempt to tackle this solid-state dilemma. Greg, Neil, let's take charge. Greg, Neil, thanks for coming on the show.
Thanks for having us.
Thanks, Jamie.
Really looking forward to talking about ion storage systems, and we've got an interesting lineup ahead of questions. So thank you for coming on. Before we get into the details, let's start with your backgrounds. So Greg, maybe let's start with you.
Yeah, absolutely. So I'm Greg Hitz, the CTO and co-founder of Ion. I've been working on high-impact technologies my whole career. Started doing research and development into microbial fuel cells, converting sewage to electricity. Super interesting technology, but actually found out that there's really not that much energy in sewage, so I wanted to move on to more impactful roles. I took an operations role where I was one of 20 people on the planet who was responsible for making this life-sustaining drug for patients that needed it. That was very impactful on me because I realized that technology is great, but where you really make a change in the world is when that technology reaches the hands of the people who use it in the form of a product. So as I was looking for work for my PhD research, I wanted to work on batteries. They're the oil that's going to power the world. But I'm just like everyone else. I see a new article every week of some amazing new battery that's going to change the world, and I still have a lithium-ion battery in my phone in my car, and that didn't fit right with me. So really set about a search for a battery that could do it all. And what I realized is that all these amazing new batteries solve some aspect of the next problem, but they don't solve a holistic product. And that's where I was really inspired by this technology that is the basis of Ion. From the sourcing of the raw materials to the manufacturing to obviously the cell performance, but also critically the product integration and how it works for the customers and makes other products more powerful. It's really inspired me, and I've been working on it over a decade now. So I'm really excited to be here and talk about how we're really on the precipice of making that impact and releasing it to the world.
Thank you, Greg. And yourself, Neil?
Jamie, thanks for having us. I'm Neil Ovadia, VP of Supply Chain at Ion. I've been with the company for almost 4 years now, and I've been in startup environments for almost 20, working in kind of the earliest of foundings all the way up to public company release, and working in batteries and energy, and particularly for about 15 years now. And I've seen everything from emerging technologies, traditional technologies, and what I found is that as you're working to bring a product to market, if you're not focused on kind of the manufacturability, the ability to bring it out in scale and volume, you're not going to make it into the market. And to me, the most important thing to execute on that is the team. And when I got a chance to meet the team at Ion, I knew I needed to be part of it. I just immediately needed to join that group because it was such a well balanced approach. And I'm excited because when I joined the battery industry, it was a $400 million industry, and I almost fell off my chair at that point. At this point, the market keeps getting adjusted upwards. Way beyond 400 billion, and probably somewhere around 4 trillion by the time I retire, hopefully. So great to be on the podcast. Excited to get a chance to chat with you.
Brilliant. No, thank you both. And I think it's a really nice dynamic, you two coming on to talk about, as you say, manufacturability and then, as you say, Greg, the more technical side and innovation side. It's such a fast moving industry, but yet we still have the same battery in our smartphone, and there's still lots of work to do on the EV side, and many applications. So yeah, I'm sure we'll see a lot of progress in the next 5 to 10 years. Let's start with solid state, and first of all, the history of solid state. So, Greg, talk me through when it all started and kind of where we are today.
Yeah, it's a really interesting question because there's all this buzz recently about solid state batteries, but there's nothing new about solid state batteries. It depends how you look at it. The first development started in the 1800s of the the iodides and fluorides. And there have been innovations along the way that are all primarily materials innovations. LiPon and the NASICon, LISICon classes, and the culminating most recently with the garnet, the lithium garnet class of materials, which is what our technology is based on. But what we realized is that if you look at the shortcomings of solid state batteries, and in particular the commercial shortcomings, they all relate to the structure, the manufacturing, uh, and the integration into products. The trade-offs. I always say a solid state battery always comes with an apology. It's really great, it's safe, but you have to compress it, you have to heat it, you have to do some kind of crazy thing to it to make it work, and that doesn't work for people who want to just use batteries to make their products better. So that's where we've changed the form of innovation to not being primarily a materials innovation, but taking the material sets that exist and developing a product solution based on them.
Great. And why do we still not have a commercialized solid state battery? As you say, it's been around for a very long time.
Right. It's a couple of the things I said. First of all, really, I guess the question is why solid state? We go to solid state because it's safe. Uh, but most people aren't buying a battery because it's safe. They want a better battery that's also safe. So when you use solid state, one of the key opportunities is that you can use better electrodes for better energy density. And really that best electrode you can go to is a lithium metal anode. And the problem is then when if you have this planar system and just flat layers of each material, then you plate the lithium metal and the cell expands, and then you strip it away and the cell contracts, and then you need a huge amount of pressure to hold it all together and make that battery keep working. And when you look at the implications of that pressure, it's anywhere between, if you look at literature, 3 to 300 atmospheres worth of compression. And even at 3 atmospheres, you're still talking about a pretty significant amount of pressure. Cell phone size battery would be about 200 pounds of force you'd have to apply. An EV battery is at least an order of magnitude more than that. So that means, from a commercial perspective, you're jumping into markets that can handle complex battery pack integration and can't address, more diverse markets that suit the business needs along your way to that. So the compression requirement, oftentimes, solid electrolytes are less conductive. That's not so much the case anymore, but that would require heat being added. Uh, you know, there's also this idea that solid state is safe, but there's no such thing as solid state as one item. It can mean many different things. If you have a sulfide electrolyte, you might create the opportunity for hydrogen sulfide production and a safety issue. Maybe it won't burn, but it still won't be safe. So really taking that holistic look and addressing all of these issues together. And nowadays, battery customers are getting even more sophisticated. They're having requirements put on them from the governments or just internal corporate policy for sustainability and circularity. What do you do at end of life for the battery? And then swelling issues. They recognize that in an iPhone, you leave about 10% extra space just for swelling of the battery. In a market where every micron gets shaved down, the battery guy comes in and says, "Leave me a bunch of air and don't put battery there." So really, that the short answer to your question is you have to think of the customer's needs and develop a solution that makes the customer look good, and not just focus on the cell itself and making a nice graph of performance.
Yeah. Some
As
great.
a relative newcomer, Jamie, to solid state, I was kind of surprised that it predates lithium ion by a good couple of decades, actually. And learning more and more about solid state technology, it has the potential of being a new benchmark technology. And the main reason why I think it hasn't been fully commercialized is it can be, you know, transformational in any one of the performance metrics, but you've yet to find a technology where it's uncompromisingly transformational throughout. So you've got a true platform that just does everything that gives you that solid state promise, and just entirely replaces the incumbent.
Yeah. And you mentioned before, Greg, end of life. We're going to talk about end of life a little bit later and the importance of that. And yeah, as you say, Neil, predating lithium ion just seems crazy that we are still where we are today and so much potential yet still to be realized. When we initially spoke, I was fascinated by your three-dimensional approach. And I didn't, if I'm honest, fully understand it. So, Greg, it'd be good if you could help me understand that.
Right. So, the conventional way to make a solid state battery is you have your cathode and you have a layer of electrolyte and then either a layer of some anode material or you just allow lithium to plate on the other side of that planar surface. And that's what creates a lot of these challenges of the compression requirement and the expansion and contraction during cycling. And so what we realized is you have to solve that what you're ultimately doing is taking lithium ion and creating lithium metal in a place where there was no material previously. So what we have is a multi-layer structure. We have a dense separator, just like everyone, but we also have a porous structure on top of that creates a scaffold that lithium can plate inside of. So there's a number of advantages there. First of all, it's 50 times the surface area, so the actual lithium flux across that surface is much lower, which means that the transfer challenges. One of the hardest parts of a solid state battery is that interfacial transfer. We have 50 times the interface, so it all happens inside of these pores. That also means that there's no external volume change. We've accommodated this mass that we're creating and volume that we're creating inside of the pores, and that means that from a cell level, so I have some props here. Sorry for anyone listening.
Nice.
So you have the dense layer and porous layer. So this is our anode right here. What we do is we attach that to a current collector foil and create what's ultimately a double-sided anode. It's white instead of black, but otherwise it's pretty much what you would get for a double-sided graphite anode. So then you can take that and treat it just like any other anode, assemble it into a cell, and take advantage of the lithium ion ecosystem for manufacturing. So it's this approach that basically handles that lithium metal in a very efficient and high performance way, all within the anode structure that we've created.
Brilliant. No, thank you. You say 50 times the surface area.
Right.
Wow, it's impressive. And then, I guess, Neil, moving on to you, I'm fascinated to learn more about your obviously expertise and background in the manufacturing and supply chain. A huge issue right now is manufacturability and scaling that, and the capital that obviously is needed to succeed when it comes to solid state. Do we need to reinvent the wheel? And kind of is using existing blueprints and methods the best way to make this happen?
In some ways, I think yes. In some ways, no. I'm old enough to remember when the word gigafactory was coined, and at the time, it was a giga problem that we were looking to solve, in terms of demand. But at this point, we're really looking at terafactories, right? The ability to really support global demand. And funny enough, we were looking up the word terafactory to see if it had been coined yet, and spell check did not recognize it. So terafactory is not yet on everybody's radar, at least. And I think when it comes to manufacturing at scale, there is no existing blueprint to manufacture at scale for solid state batteries. And so our focus, it was a premeditated choice from the beginning, to make sure that making a lot of our batteries wouldn't be science fiction. It would be an industrial reality. And so what we did is we looked at each one of our manufacturing processes and looked at adjacent industries and adapted established industrial methods that could meet that terawatt hour demand, that could meet it globally, and that could meet it in a way that was sustainable and responsible. And what we've done is built out a network of partners and processes that allow us to manufacture at these amazing scales while also reducing the necessary footprint for manufacturing. And so we're very agile in that way. So no, we haven't really reinvented the wheel there. We've just used the best processes and industrialized methods out there and just adapted them. Where we did really modify and reinvent the wheel is how we've looked at supply chain and materials. We're working with better materials. We're working with locally or sustainable materials. We've got a good focus on circularity and sustainability. Our platform allows to not use nickel or cobalt in the cathode. We're highly agile and able to adapt to whatever cathode we're looking for. And then we don't use some of these materials that we found are becoming a kind of bottleneck for growth. Graphite in the anode, nickel and cobalt on the cathode side, things that are very particularly geolocated. And then finally, for me, something that was very important was sustainability. Approach towards net zero and circularity. I think we've chosen our partners diligently in terms of their approach to net zero manufacturing. We've removed solvent from our manufacturing processes, and we're working on true circularity of a battery, right? The ability to maintain residual value and revive that battery over and over again in kind of a novel regeneration method.
Very good. You mentioned materials and distribution. We're going to get into geopolitics a bit later, and what's affecting that. So yeah, thank you for the insights there. Going back to something you mentioned earlier, Greg, on compression. Let's get a little bit deeper into what compression actually is and why your technology doesn't require it.
Right. Yeah. So that structure that we make, the multi-layer structure with the porous scaffold, that's where. So to get into details. So when we charge our battery, we plate lithium metal into those pores. And when we discharge it, that lithium metal strips away and goes back to the cathode. What we actually do is we manufacture our batteries anodeless or lithium free. So what that means is we take that ceramic structure with zero lithium in it and connect it to the current collector. And that lithium all comes from the cathode and plates in on the first cycle. So that's a much more manufacturable way compared to dealing with the kind of sensitive lithium metal that reacts with everything. And the lack of need for compression really mostly comes from that discharge cycle. When you have lithium metal and you start stripping it away, the lithium metal turns into an ion and moves through the pores or through the electrolyte, and that needs to be backfilled with more lithium. And you can either do that by applying a huge amount of pressure or minimize the distance that you're pulling that from. There is some amount of movement within the lithium metal. And so having these small pores allows us to, pull from, it's almost like if you're, if you're digging a pit of sand at the beach, if you take a giant pit, it's all gonna, you're gonna leave a pit. But if you slowly dig a hole, the sand's gonna, the wind will take it in and it'll refill as you go. That's really what we're doing is slowly pulling from that surface. But like I said, there's 50 times the surface area. So, we haven't reinvented physics here. What we've done is engineer around it. And that's where, when we take our batteries, so again, sorry, holding up a prop, it looks just like a lithium ion battery. There's nothing special here. It's a pouch cell. And if you walk into our lab, you'll see them cycling, and they just sit out on the, in the thermal chambers or on the counter, just like this. There's no compression, no clamps, nothing like that. And so that's when we say no compression, this is a regular pouch cell. We make it just like a lithium ion cell, and it sits there and it cycles. And so we're harnessing the physics at the surface with the design of our cell, as opposed to accommodating it after the fact with an apparatus. And if you look at pictures of kind of the alternative, there's big metal plates and springs and bolts. and you actually can't even see the battery itself when you look at the other way to do it.
Great. And what does that mean for, I guess, both manufacturing but also application areas? Because I remember at the beginning, Greg, you talked about what inspired you to kind of really move into this industry and make a difference was the fact that we still have a lot of the same products that we've always had. So yeah, what does it mean in terms of the application areas first of all, and then also manufacturability?
Right. So, a lot of this comes from the advice of a wise man. Mike Tyson said everybody's got a plan until they get punched in the face. That's pretty much what manufacturing is. You think you know how to do it, but until you actually do it, you haven't learned the hard lessons. So, it's our perspective that, you know, scaling directly to a gigafactory is not the right way to do it. And we don't have any special insight here. Everyone is aware of that. What we have is the opportunity to do it in a smarter way. Like I said, if you have to apply 200 pounds of pressure to go into a cell phone, you're not going to do that. So these alternative, our competitors that require the pressure, they're jumping directly to electric vehicles because they have to, because they need that complex battery pack. And so that path makes sense given the limits of their technology. What Ion is able to do is go to these more niche markets, spin up a smaller amount of manufacturing at a less price sensitive market, and deliver to customers that are really focused on the energy density, the safety, the high temperature operating capabilities, and really give extra value, learn the hard manufacturing lessons as we go, and actually we believe we'll be scaling to EV faster because we'll be in manufacturing and developing that learning in a in a smarter and more efficient way.
Great.
Hey, Jamie, I'll add to that. I mean, if you look at kind of one of the most important performance metrics for a battery, or at least people who make batteries know, cost is a critical performance metric. It's usually not viewed that way, but being able to remove complexities, not just from the battery, but from the ultimate assembly that houses it, is just going to further the ability to get those batteries into different products. And when you look at the difference between a niche technology and a true kind of benchmark platform, you need to be able to be the battery for all market segments, right? You need to be able to support them all. And if you can do that, you have the added value of supporting, multiple second life applications, right? When a battery goes under its kind of 80% capacity, warranty or use life, it doesn't just get discarded. It goes out to multiple other second life applications, and I think a true platform technology that can support those multiple second life applications is key towards electrifying a lot of the industries we're looking to electrify in the next couple of decades.
Brilliant. And just to summarize, so in terms of application areas, there's no limitation. I guess you're kind of looking at all different markets.
Yeah,
So we're equally focused on defense and aerospace, consumer products, electric vehicles, grid storage, the medical industry. I think our unique abilities in terms of our technology allows us to really support the needs of all these different markets. In particular, the fact that we're adaptable in terms of our cathode approach. It's an agnostic approach towards the application. And I think our ability to scale manufacturing to meet their needs, at both the low and high level, without requiring materials from overseas, makes it highly appealing to a lot of these market segments as well.
It's
my
exciting.
my succinct description would be wherever lithium ion can go and more. There's actually still military applications where they're using lead acid instead of lithium ion, and it's not for any other reason other than lithium ion is not certified for certain aircraft, because it's not safe. So developing a safe battery, you're competing with the energy density of lead acid.
Hmm.
So wherever lithium ion can go and more is where I would say we're targeting.
Nice. Yeah, you mentioned that safety. In a previous episode, we had Soteria on the show, focused all on safety, and they were talking specifically about e-bikes and the amount of battery fires they're having. They're doing some great work to reduce that problem, but it won't be 100% of the problem because it's still lithium ion. Whereas if this does take off, no pun intended, then as you say, the kind of military applications and many different applications are 100% safe, or say 99% safe. So no, very exciting. Before I
I
forget,
think it's important to look at that, Jamie, is that, there's a lot more energy being placed in closer proximity to our bodies, in our homes, right? Safety is a true challenge for lithium ion batteries as we're growing the amount of just energy. I've got batteries in my ears with real amounts of power in them. 90 kilowatt hours worth of battery in my garage. My cell phone sits right next to my head when I go to bed. I think the consumer is starting to understand, wow, there are batteries all around me all the time. Safety is not something that should be taken lightly. It's certainly not for us. We take it very seriously.
no, definitely. I was going to say before I forget, have you trademarked Terra Factory?
I'm working on it. It was something we recognized a few days ago, and I'd love to have a Terra Factory with our little plus sign at the end.
Yeah. When you told me the first time you spoke, I was like, Terra Factory. I've never heard of that before. Am I being stupid, or because I've never heard that? So there you go. Do it quickly is what I would say.
Brilliant.
So getting deeper into scaling your technology, kind of how far down the line are you, and what are your future plans?
I mean, we're making great progress there. We've got our pilot manufacturing line. It's semi-automated. It's been installed and commissioned in our pilot manufacturing factory in Maryland. And we've got all of our scalable manufacturing processes in place. And we've begun working with an all-star team of partners to scale. We're not a traditional battery factory in that we recognize there are folks that have industrial capabilities and knowledge that spans back over 350 years. One of our main ceramic partners, Saint-Gobain, is a 350-year-old company with capabilities in ceramics that are just immense. And so we're excited to work with these types of partners. And there's going to be more to be announced soon. That are giving us not just the capability to scale quickly as needed, but also to scale where needed, right? They've got a global footprint. And I think what's critical and key now is the product that we're producing on our pilot line today is our first market product size, right? There's not some exponential growth of the product that still needs to happen to be able to achieve, first market entry. Our pilot line is configured to start producing those batteries, at a pilot scale, but for these customers at the size they require. And so I'm highly excited about where we are, and extremely excited about the network that we're building to kind of be able to execute on that.
Very good. And again, when we were speaking before, we talk about the order in which of doing things. Is it important to get scaling strategy in place first, or is it important to assemble the right team first? Does that then determine your strategy? Talk me through that, because I know there's something you've done quite a few times before, Neil.
I mean, there's no real textbook for how to make a solid state battery, right? There's no plan to go follow and just execute against. And I think Greg knows this better than me as the founder of the company. He had a vision for what he wanted the team and the company to look like, and I might as well turn it over to Greg because I won't do it justice.
Yeah, I'd say the team is everything, and that includes internal and external. We built the company from the start. I think one of our first 5 hires was not a scientist but an engineer, and in our first 10 was operations people. I know you have to build yourself as a manufacturing company from the start, and really embody that mindset. And that team internally is critical. I'd also point again to the external team. We built this all-star network of partners, and we didn't do that to deliver on our first market product. We did that because we could for our first market product and use that all-star team to scale together to address the really hard challenges of a Terrafactory. And I'd really call out the Saint-Gobain team. It's like we have 400 extra employees. They hustle their butts off for us. We were dealing with an issue one day, and they got in the car at 3 a.m. to come down and help us out. That's the kind of partner that makes us successful, and we do everything we can to be the right teammates for them too.
Wow.
JB, let me add something from my perspective because I think, to me, it was critical. It was what made me join the company is we have balance at our company, right? We've got a CTO that has been living and breathing this technology. And we've got a CEO whose main focus for the last 2 decades has been making batteries, right? Billions of them. And so you've got this great balance between the technology and the operations, the manufacturing. And we've made premeditated choices from the start of the company to really not just develop something that will exist at the benchtop level, right? But will be made in mass and focusing on how it will be made in mass, what the cost is going to be, performance metrics that go beyond the technical capabilities of the battery, but really looking at the performance metrics that are also required to bring it into the market profitably.
Right. And remind me, sorry, your CEO, is his background with Apple? Is that correct?
Right. So Ricky was the executive in charge of battery manufacturing for Apple. So for 4 years, every battery they manufactured was his responsibility to make sure it was high quality, safe. And when I say quality at Apple, the mandate is that every single internal part is museum quality. That a reviewer could take it apart, lay it out on a table, and take pictures worth putting into an article for every single battery or every single iPhone they make, every single product they make, and that went to the batteries too.
Brilliant. So good personnel on board to kind of help with this next chapter. And as you are looking at achieving your manufacturing goals, what do you see as your biggest challenges ahead, especially when it comes to solid state?
In a word, quality. A fun quote: Elon Musk has said that manufacturing batteries is the hardest thing in the world, and he's a guy who lands rockets on their tails. And he's even just talking about lithium-ion batteries, not the solid state batteries that today are more of a challenge to manufacture. Quality is an extremely high bar in batteries. You have to make millions of batteries per day. They carry a lot of energy, and so they need to be safe and they need to be well made. So at Ion, what we've done is from the start, one of our first 10 hires was a QC person and built a QC department before we even had a process in place. 20% of our footprint is quality systems, and probably about that level in a percentage of our personnel as well. So really building that quality mindset into everything from the start is the biggest challenge and is our biggest focus.
We've talked quite a lot previously about barriers to scaling. Was in the past it's been gigafactories, but let's talk about terafactories instead. Actually, housing these with talent is a huge issue. So, what do you see as solutions for this when it comes to housing our future terafactories?
Yeah, I don't think it's new to anyone in the battery industry that recruiting personnel is a big challenge and a big time investment. And if you look at the Bureau of Labor Statistics said that in 2030 there's going to be 10 times the workers in the battery field compared to in 2020. And that means that 90% of our recruiting during that period needs to be from outside of the battery industry. So who do we look for? We've recruited from the electronics industry, from Intel and silicon wafer fabrication, from the concrete industry, some of the mixing processes they use, uh, paint industry. We like coatings of things, and so a lot of the techniques there are adaptable. Floor coating, biotech. Really, it all starts with identifying the problem. And so again, to bring it back to quality, if you have the right quality systems, you can define what you need out of a process, and then you can go define that for others. And in some cases, it spurs a relationship like with Saint-Gobain. and the powder supply agreement we signed with them. And in other cases, it spurs a job description that you go hire, the world's best expert in thin slurry coating. And so, when you define the problem that way, you don't need to go hire a battery expert. You go hire an expert in the process that you're looking for, and that's really been pretty transformative. There is a certain adaptation that people have to go through, and that's where government, in particular, investment in training programs is very helpful. But we also at Ion have a very rigorous onboarding procedure to make sure that people get up to speed very quickly with what our technology is and what the challenges are, and they can bring their expertise and lay that on top.
Nice.
I think, Jamie, just to add to that, when you're trying to create a transformational technology, any type of emerging technology, you need a glimpse of that rebelliousness to you, right? You don't want to just do what's been done before because you're not going to make anything new or better, right? You want to challenge some of the status quo in terms of how batteries are made, how they're thought about, right? And you want a team that's really looking to make a difference. And I think for me, that's one of the biggest difficulties working in batteries for so long is you forget how monumentous the challenge that batteries are trying to fix in the world, right? It's this electrification of everything, and there's no traditional battery employee. I'm an English major, for instance, working in batteries for the last 15 years. Typically I have no place working in the battery industry. Yet, I'm excited about what I do, and I think the team we've built at Ion has a little bit of that rebelliousness that allows us to think out of the box and really solve the biggest challenges that we have. And it's something I'm really proud of.
Great. No, thank you, Neil. And I'm also interested to get your insight on material accessibility, given your background in supply chain. Greg mentioned before kind of geopolitics and accessibility to materials and abundance of materials. With everything that's going on right now in the world, how do you see that panning out, and how can battery companies get ahead of this?
I mean, as you look at the growth of demand for batteries, it's a global thing, right? It's not located in one particular area, and the growth itself is going to be difficult to sustain from one particular region of the world. And so, batteries and battery supply chains need to be thought through again in terms of how we're approaching them. We need to understand that technologies that are limited in the capabilities of materials that can be resourced to be used for these batteries are not going to have a long-lasting future. You need a platform that's adaptable to the region that it's being manufactured in, to the applications that we're trying to focus on, and I think that's particularly what we've been finding in the last 18 months. As you see the news start growing about graphite shortages, issues with sourcing lithium, nickel, cobalt. We approached this from the start, realizing that we really need to have a technology that's agnostic and enables cathodes of the future as well. We need sustainable manufacturing, something that doesn't do more harm than good at the end of the day. And we still need to be able to meet that terawatt hour demand. And so we've approached it in a way where there's three main parts, right? The initial design of the battery is able to adapt to the changing requirements from a materials perspective around the world. We have nothing that's geostrategically sourced. We are able to utilize highly sustainable manufacturing techniques, reducing footprint, reducing the requirement for power. And we're also able to regenerate and give these batteries second life applications, which means we're not beholden to any particular region that supplies materials. And we've got, with our network of partners, a global reach in terms of where we can manufacture these batteries as well. And our cell assembly footprint, I think we didn't really cover this, is because the battery is very similar in its assembly methods to lithium ion, relies on pretty much traditional high-speed lithium ion manufacturing techniques as well. And so very small footprint, can be deployed anywhere, can be deployed very quickly. Right, our manufacturing line was built in, I think it was 6 months, and so we're able to support big market segments, small market segments, and scale appropriately as well. And that's really exciting for the future of battery and electrification.
Great. You touched upon end of life and second life of batteries. Just today, a coincidence, I saw there was a huge explosion in France in a storage facility where batteries are ready to be lithium-ion batteries ready to be recycled, and it just kind of highlights the importance of end of life. Should this be something that battery manufacturers and battery technology businesses take more responsibility for internally? Or is it a more effective method to have dedicated companies focusing on battery recycling? And based on that, what is ION's plan?
I think we're seeing a couple of things. The consumer is definitely requesting a much more responsible approach towards their batteries. You're seeing regulation, particularly in Europe, around circularity of batteries, the recovery of the materials, and I think that regulation will eventually find its way in the U.S. as well. And so a responsible approach to end of life is critical. What we don't realize is most battery users, in terms of kind of product manufacturers, they see end of life of batteries as a liability they have to deal with, mostly because there's no real value in these batteries at end of life, particularly because volumetrically there's not much in terms of what you can recover. The graphite is not really that meaningful. A lot of the manganese and other materials is not very useful. And so you're really recycling just a small portion of the battery. I think as you look at solid state and on our technology in particular, there's true residual value in the battery at the end of life, right? The anode is actually something you can recover and regenerate and reuse over and over again, which is great. And you're able to support multiple second life applications as they move from segment to segment. And I think our plan is to try and push the boundaries of circularity and sustainability to really see how we can provide a responsible product out to the world, how we can give the consumer value at end of life when it comes to their battery, and how we can build that circular kind of strategy to recover these materials and make them a responsible option in terms of batteries.
I'd add one thing to that. Kind of going along with the ION philosophy is being responsible for the entire problem, but also recognizing that the solution for each of those individual problems may be internal to ION or it may be external. We found, Saint-Gobain's, powder production approach as this really phenomenal, scalable, suitable for recycled input material approach, and are very happy to have them as part of the plan. When you look at end of life, it's very similar. We as a cell, developer and manufacturer need to be responsible for the solution, but that doesn't mean performing it ourselves. So I've already partnered with Saint-Gobain and one other company to map out and develop that end of life situation.
Yeah, a really good point. I think it's something a lot of companies, not just in batteries, can be guilty of is trying to do too many things. Rather than using specialists who are way more experienced and they have dedicated resources to it, and ultimately can take liability as well and kind of be less stressful internally. But I think it's a really good point and something that battery organizations, from having conversations, should look at more. Make sure that you specialize in that one thing or two or three things rather than trying to keep everything in house. So yeah, good answers. Things seem very exciting right now at Iron Storage Systems, but over the next 3 years, what are you guys most excited for?
Yeah, so where we are now is we've developed the best anodeless cell on the planet, and we have a pilot line, ready to crank out a lot of these cells. And we've been kicking off, evaluation programs with some of the biggest companies in the world. So over the next 3 years, we're going to be, doing commercial release of products for our first market products, for the subsequent products, going into some military applications, consumer electronics, and making those deeper partnerships in electric vehicles, scaling up the manufacturing to address these markets. Many more partnerships to be announced. Batteries have lots of challenges, and we found a number of partners. The first one to be announced was Saint-Gobain, but we have a number of other partnerships that are crystallizing and going to be announced in the next few years. Growing the ION team to continue the rapid development towards the EV product capability, and in particular, keeping in mind the top three performance metrics of EVs, which are cost, cost, and cost.
Very good. As a closing tradition, I'd like an answer from both of you. How do you think the battery world would look in 10 years' time?
I mean, I think we're seeing it now, right? You're seeing batteries starting to just show up everywhere, right? Your vehicle, your home, all the products you're using. It's become a ubiquitous kind of need or almost a right? You demand energy, you demand it where you need it, you demand to be able to use it how you want, right? And I think um, I find a couple of things very interesting is customers, of electric products are starting to pay more attention to the batteries they're buying. I was actually shopping for my first Model 3 Tesla, and I walked into the dealership, and I was intrigued to hear a conversation between a husband and wife who were going to buy one as well, arguing whether they wanted the NMC version or the LFP version. And I said, "Wow, that's pretty amazing that the typical consumer already knows about cathode technology." So I think in 10 years, people are going to really understand and have demands for what they want, right? And getting those batteries is not going to, feeding their needs is going to be something that's very important. Along with that, I think battery manufacturing is going to be a lot more globally dispersed, right? I think there was a push in the 90s to really move battery manufacturing to Southeast Asia, and I think that was a lost opportunity in the US. But now there is really a globalized approach to battery manufacturing that's highly regional. And I think it's going to be interesting to see how different countries and regions really approach batteries and electrification in general.
Yeah, along the manufacturing lines, if you look 20 years in the past, the way we manufactured lithium-ion batteries was very different than the way we manufacture it today. The cost goals and the cost down has really changed the way we manufacture batteries, and I think that's going to continue and be totally flipped on its head with the solid state batteries. Uh, when you look at the cost goals of $100 per kilowatt hour for EV, and really that goes for every market. Uh, and in particular, the geopolitical resource, targets. If you're making a battery with inexpensive materials and you have incredibly tight cost goals, it doesn't matter if you're making it in Shenzhen or in Huntsville. You can't be paying a lot for labor either way, so it's going to be a highly automated process. It's going to be not it's going to be using very resource available materials, and that means that you can do it anywhere. Your core costs are land and power. So you have to build a blueprint, and that blueprint is going to be portable to wherever you want to go. So in a sense, while battery manufacturing is going to be getting bigger, it may also get more local.
Brilliant. Now, thank you both. Some really good insights. And before we finish, Neil, I'd like to praise you on your use of the word ubiquitous. Using that,
Ubiquitous.
yeah, using that English major, put it to good use.
There's a few moments that I get to actually enjoy that purpose.
No, it's good. Terrafactory, another one. But no, very, very good, very, very interesting insights there. And that when we initially were speaking, I was fascinated by your approach and your technologies, and also the team that you have internally to make this a reality. So, I do truly wish you the best over the coming years as you look to scale. Yeah, thank you very much. And in terms of finding out more about you, of course, we'll we'll provide links to the website and everything. But is there any, if anyone wants to find out more about ion storage systems, to become a partner of yours, is the website the best place for them to go?
Website, LinkedIn, info@ionstoragesystems.com. We're always excited to grow our network, always excited to kind of speak to talent who'd like to join the company. Feel free to reach out in any which way.
Brilliant. Well, thank you both for coming on the show, and yeah, good luck for the rest of this year.
Jamie, it was a pleasure speaking to you. Thanks for the chat.
Thank you. It's great to be here.